Welcome to this introduction to number sequences. A number sequence is a list of numbers that are linked by a rule. Consider the following number sequences: 1, 4, 7, 10, and 13. These numbers are in a sequence. Can you figure out what sequence these numbers are in? These numbers are progressing in this sequence by adding 3. 1 plus 3 is 4. 4 plus 3 is 7. 7 plus 3 is 10, and 10 plus 3 is 13. Another example of a number sequence: 1, 3, 9, 27, and 81. These numbers are in a sequence as well. The sequence is progressing by multiplying by 3. The first number, 1, multiplied by 3 is 3. Then 3 multiplied by 3 is 9. 9 multiplied by 3 is 27. 27 multiplied by 3 is 81. Here's another example of a sequence. I love this sequence. This sequence is being arrived at by adding 2 previous numbers. So if we add 0 and 1, we get 2. If we add 1 and 2, we get 3. If we add 2 and 3, we get 5. If we add 3 and 5, we get 8, and so on and so forth. Here's another sequence: 1, 4, 9, 16, and 25. This sequence is being arrived at by the squares of their position in the sequence. The first number, 1, the number 1, is the first number, and if we square it, if we square 1 squared, we get 1. This is at position number 2. If we square 2, we get 4. 9 is at position number 3. If we square 3, we get 9. 16 is at position number 4. If we square 4, we get 16. And 5 squared is 25. Types of sequences. The first type of a sequence that we will learn is the arithmetic progression. An arithmetic progression, or an arithmetic sequence, involves a sequence of numbers to which the same amount has been added or subtracted. Examples: 3, 5, 7, 9, and 11 is an arithmetic progression. To the first term, 3, we've added the same amount, which is 2. And to 5, the second term, we've added 2 to get 7. And to 7, if we add 2, we're going to get 9. And to 9, if we add 2, we'll get 11, and so on and so forth. This is how this sequence is progressing. Another example of an arithmetic progression is 11, 9, 7, 5, and 3. Notice what is happening here. To the first term, 11, we subtract 2 to give us 9, and to the second term, 9, we subtract 2 to give us 7, and to 7 we subtract 2 to give us 5, and to 5 we subtract 2 to give us 3, and so on and so forth. The amount that is added or subtracted is known as the common difference, and the symbol for the common difference is D. Please remember this. The common difference is symbolized by D, and it is the same amount that is added or subtracted to an arithmetic progression. Each of the numbers in the sequence is called a term of the sequence. Consider the following sequence: 3, 5, 7, 9, and 11. The first term, 3, is symbolized by T sub 1. The second term of the sequence, 5, is symbolized by T2. The third term of the sequence is symbolized by T3. 9, the fourth term, is T4. 11, the fifth term, is T5. Generally, we symbolize the sequence, the terms of the sequence, by Tn, where n is equal to 1, 2, 3, 4, and so on and so forth. Other symbols used in sequences. A represents the term 1, the first term. In this particular example of the sequence, A is equal to 3. D in a sequence represents the common difference. The common difference is calculated by subtracting the preceding term. Example: D will be calculated by subtracting T1 from T2. D can also be calculated by subtracting T2 from T3. D can also be calculated by subtracting T4, by subtracting T3 from T4, and so on and so forth. I repeat, the common difference in an arithmetic progression is calculated by subtracting the preceding term. The second type of sequence which we are interested in is the geometric progression. A geometric sequence is a list of numbers that are multiplied or divided by the same amount. Consider the following geometric progression: 1, 3, 9, 27, and 81. This geometric progression is progressing by multiplying the preceding number by 3. 1 multiplied by 3 is 3. 3 multiplied by 3 is 9. 9 multiplied by 3 is 27. And 27 multiplied by 3 is 81. Example number 2. 16, 8, 4, 2, 1, and so on and so forth is also a geometric sequence. And this geometric sequence is progressing by dividing by 2. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1, and so on and so forth. The amount by which the numbers are multiplied is known as the common ratio. So in example number 1, the common ratio is 3. The third type of sequence is known as square numbers. In a square number sequence, the terms are the squares of their positions in the sequence. Example: 1, 4, 9, 16, and 25 is an example of square numbers. Their positions are squared. The first term 1 is position number 1, and 1 squared is 1. The second term 4 is position number 4, and is position number 2, and 2 squared is 4. 9 is position 3, and 3 squared is 9. 4 squared is 16, and 5 squared is 25. Lastly, in this introduction to number sequences, we shall look at the fourth one, which is the Fibonacci number sequences. In a Fibonacci number sequence, the terms are found by adding the two previous terms. Example: 0, 1, 2, 3, 5, and 8 is a Fibonacci sequence. The numbers are progressing by adding the two previous numbers. 0 plus 1 gives us 2. 1 plus 2 gives us 3. 2 plus 3 gives us 5. And 3 plus 5 gives us 8. And so on and so forth. Note: the Fibonacci sequence always starts with 0 and 1.